Good evening, ladies and gentlemen. Good morning, good evening, good day, good afternoon, all of the above. Welcome to Monday. Hope you guys had fantastic weekends. I know I did. I had a good fun. What do you guys get up to? Yay. Oh yeah, we've got an emote. I haven't actually seen anyone use that emote before, so you are the first, Combos. It took like a week or so for about a week for the emote to be approved, which I don't know whether that's fast or slow, but hey, that's just me going, So feel free to use that whenever you see fit. I've got some other ones coming. I'll probably put a get system one together, but that's only going to be for people who are willing to pay for it, because I got enough get system jokes as it is from every angle. Okay, so where are we up to? I just had to boot my VMs behind the scenes because I forgot. But anyway, let's not forget that hacking without tea is very uncivilized, so make sure you have your tea or beverage of choice for those people out there who do not have kettles unpacked. You know who you are. But anyway, welcome to the stream. Wolf, Engels15. Is that Deraven? Yes, it is. Smash, Gombos, Command Control, etc. Thank you for joining in as always. It's nice to have you regulars chiming in. Hello, MXDSec. Welcome. Oh, tea is so good. So yeah, I've got the Dongding again tonight. The T2 Dongding Oolong tea. Remember, it's very important. Don't brew for any more than 3 minutes, and no hotter than 80 degrees, preferably a little bit cooler. Otherwise, you end up with a really tanniny and bitter brew, and no one likes a bitter brew. So make no mistake, that can really ruin your day when you have a terrible, terrible tea. This tea is not terrible. So, okay, so where did we leave off? We left off last time. Hang on, let me bring my VMs up so you guys can see them. Where's the magic button? There it is. You guys can see that. Yep, there we go. Still got the blue screen. I'm going to change that this week at some point. And hope you're doing well. Thank you, mate. I'm doing very well. Thank you for asking. I appreciate. Thanks for doing the streams. I appreciate your gratitude. I hope you're enjoying them as much as I do. I get a bit of a kick out of it. It's always nice to share a bit of knowledge and underlying sort of magic that Meterpreter is, which actually, I mean, it's a magic peter kit, but understanding it's not that hard, but it helps to have someone sort of walk you through it, and thankfully I'm in a position to be able to do that, so it's good. Hey Bandit, OJT, yeah, I need an OJT emoji, whatever it's called, emote. I'll probably start working on that, having me drink a cup of tea or something. That'd be good. Okay, so where we left off last, we were sort of in a bit of a mixed position. We were looking to figure out a way of getting things staged. We were parsing configuration. We were implementing extra transports, that sort of stuff. And what I think is probably worth doing today is expanding on that a little bit and probably getting the MSF side involved a little bit. So that'll be good. Jimin Zero, thank you. Thank you for joining in. Welcome. So it's probably worth us starting to muck around with the Metasploit side at this point, because I think it'd be useful to see how we can wire our existing modules, our existing code from the Meterpreter side into the Metasploit side of things. Oh, I've just had another follow. Oh, it's not a follow, it's a sub. Thank you, Eric. You're a legend, my friend. I appreciate the sub. Did you do that for the emotes? Should add more emotes. Thanks for the sub, buddy. That's really kind. Okay, so what we'll do is I'm going to come back over here. You probably remember where we left all this off, which is a little bit of a mess. So what I'm going to do is we're going to start by creating our very first sort of Meterpreter.net stager. We're not going to go with stage list to begin with, because I think well, clearly we're not in a position where we're able to generate stageless payloads. And it's probably worth like being able to generate a stager and rinse repeat it. But I think what I'll probably look to do to begin with is not necessarily generate a stager. So that is, I won't generate any C#, I won't generate an executable or an ASPX or anything like that. What I want to focus on is the staging process. So the stager that, with the inverted commas, stager that we've got running over here, which has this simple TCP stage test, this is going to remain like our hard-coded stager for now. What we wanted to be able to do is validate that we can get this stuff down, and then we can parse metsrv. We can load it up, and once we've done that we can continue deserializing the configuration and passing down the TCP handle to that configuration. And sort of from there, we're sort of where we left off, but we can actually get that from the Metasploit side. Now, for those who can't remember, there is a fair bit of stuff that goes on behind the scenes here, and there's one thing that I think we really need to do is attempt to at least maintain some compatibility with the way the native Meterpreter configuration comes in. So a couple of things we're going to have to do to begin with. We're going to have to hack this up a little bit because, yeah, it is a lot of tabs, isn't it? But hey, welcome to web browsers. Everyone's got a million tabs. I'm no different. I'm going to tweak this a little bit and make it so that the caller of this thing needs to pass in the file extension, which shouldn't be too much of a big deal. We can maybe default to this if it's not specified. Okay, so that'll allow us to maintain the configuration block. But there's still one thing that's a little bit of a headache for us. Now, again, just quickly recapping from last week. When we generate a stage, so that is, we pull metsrv off disk, which is what we're doing. Where is it? Here. Pull metsrv off disk, as you can see. Generate some assembly. Then once we've generated the assembly, we compile it with metsrv, and then we patch that assembly into the DLL that we've loaded off disk. And inside this patched assembly, this patched DLL, is this really important piece of information just here. So you see this, we pass in length and the RDI offset. So these values are passed in as part of here, so RDI offset and length. So we give the DLL length here, and we pump it straight into this part of the stages so that we can basically calculate a pointer of the configuration on the fly and pass that in to metsrv so that it can deserialize itself. Now, we obviously don't have this in non-native land. It wouldn't make a lot of sense. I mean, in the CLR Meterpreter sense, this wouldn't really be good. But one thing that we don't do here in the CLR land that we do in native land is actually treat this thing like an executable piece of code, right? We don't just draw a pointer straight at that line of code and go, here you go, continue. So what we're actually doing is we're pulling a payload off the wire, and we're using .NET's built-in assembly loading functionality to just reflectively load it, and then we're going to extract the type. Once we've extracted that type, we want to pass in the configuration or the binary reader from that point. So what I was thinking was, well, we don't necessarily want to change much, but there's one thing that we can do, and that's we've got a bit of room to play in this area here, right? As long as we've got what effectively looks like an MZ header, which is what a .NET binary contains anyway, right? It's still a portable executable. Maybe what we can do, instead of, as you can see, like generating Meterpreter and the configuration, gluing them together and having the length of the payload sort of implicit, maybe we can bake the length of the payload, or I should say metsrv, into this part of the PE header for our .NET executable, and we can read that in our stager. And once we've got that read, we can then do some calculations to figure out exactly where the configuration exists, right? So what we can actually do is read. We know that the first couple of bytes are going to be this MZ. We can read MZ, so skip over the MZ, pull in the next 4 bytes, which should give us an offset, and then from there we can read the rest of the the PE file, the .NET assembly, and then from there on we know afterwards we actually have the what's it called? The configuration. So my mic just played up in my head. Did everyone actually hear that? I've got this configured slightly so that I can hear myself speaking, and it seems to be kicking in and out. Are you guys getting that too, or is it just me? Everything still okay? Hello? No response? I've lost everyone already? Sounds good? Okay. Alright, thank you. That's a relief. I thought something was going wrong. Okay, so is everyone on the same page? If there's any questions around this, let me know. But what I don't want to do is change how, like up front, the payload is effectively serialized on the wire. I'd like to keep the shape of that the same. That would be really good. Hey Mugu, thanks for coming in, mate. It's nice to see you again. Okay, so this is what we're going to do. We're going to create something like this. We're going to create a payload, and I'm going to call it CLR, and we're going to have Meterpreter loader as part of that. Okay, so for now, I'm going to move this Python window rather than close it, and we will. I think I changed something here, didn't I? I'm not going to do anything with the Ruby version, so let's just git checkout this Meterpreter loader, because I don't want to continually spit out the configuration like we were. We've got enough out of our configuration dumping. And so what I'm going to do is I'm going to git pull. Oh, actually, it probably won't work, so I'll probably have to go git stash. What do you mean I can't do that? All right, let's not do that. Let me just see what I've got going on in here. So everyone remind me, we're on 2.4.2. Git reset. Hard head. Okay, git pull R7 master. So for those people who don't know, because I've got commit rights, I have a reference to Rapid7's master branch and whatnot. And that, like, I can actually push to that, but what I usually do is I pull from master and then I push to my local master. So git push to my own branch, origin master. And pro tip, if you're looking to do this kind of stuff, the best thing to do is to never push to your own master directly. Okay? Okay, cool. We've already got that up to date. I think I did that on my laptop earlier today. Okay, so git checkout -b. We're going to start with CLR Meterpreter. How exciting. Now, as a result of doing this, I'm going to go... Now, for now, I'm just going to focus on putting the payload in Windows CLR. Now, you'll notice there's a lot of stuff. Sorry, not Windows CLR, payload CLR. So I've gone one too far. Okay, so we're going to make directory CLR. Okay. Now, I'm going to take a copy of the Windows. Which one are we going to go? We're going to start with the Meterpreter loader. All right. Let's load that up. What do I do that for? See, that was me trying to be smart. Do you need two versions here? Or is that going to be another point? Good question. So my plan here is to not have two versions, but to be able to specify which version in configuration. So that's the approach I'm going to take. Make sense? Maybe a little bit confusing to begin with. So. Okay. Configuration for the CLR version of Meterpreter. So, description, inject Meterpreter and the configuration stub via assembly loading. We'll just leave it as assembly loading. Now, as much as I love Stephen Fewer, he is not contributing to this particular version, so we're going to get rid of his initials. And right now, we don't have any references. Oh, I guess maybe we do. Maybe we can cheat and put the history of the CLR Meterpreter in this particular case. So let's put History of the payload. Now, we're already hitting our very first issue, okay? What's our platform? Well, it's definitely Windows. What's our architecture? This is where things are going to get tricky. I'm going to leave this blank. I'm going to leave that blank. So this gets tricky because we're going to be running on the Windows platform, at least to begin with, and we may revisit this later on, but one really key thing is what architecture are we? Now this Arch x86 is actually part of a gem, I believe. This is where like we're going to end up in a lot of pain because we actually want another architecture. Yeah, I know, right? Oh, what happened now? I just got some crazy notification. Has used 100 bits, not like this. How is that what it is? Not like this, exactly. Alright, so what I'm going to do is I'm going to leave this as Arch x86 for now, right? And I'm going to put a to-do here. Change this to Arch CLR. Okay? We're going to come back to that because if we go and try and do this now, we're going to end up in a world of hurt. Okay? The reason why is because we're going to be diving into gem sets and we're going to be finding constants and we're going to be tweaking stuff and, you know, it's just going to be messy. So I'm going to come back and change the architecture later on. Righto, we do not need to do any assembly generation on the fly, so I'm going to get rid of that. Okay, we're going to leave stage payload the same. Okay, and we've got these configuration ops, and we're going to tweak these in just a minute. Okay. And you can see the stage Meterpreter is pretty much exactly the same. The difference will be we're not going to have these assembly values like this. Okay. So what we will be doing is we'll be going Metasploit payload Meterpreter path. We'll be asking for metsrv, plus we'll be asking for our version. Now we're going to focus on .NET 3.5. So I'm going to hard code this now, right? We don't need to load RDI DLL. We only want to load the value off disk. Okay. And what we'll do is we'll call this assembly, given that, you know, this is actually going to be a .NET assembly. I think that makes a lot more sense. Now let's whack another quick to-do in here. To-do. Figure out the version based on configuration. Now this is going to be easy to do when the time comes. Okay. We don't need to do any of this, and we don't need to bootstrap anything. What we do want to do here, instead of patching bootstraps in, we want to actually patch in the length of the payload itself. Okay? So, question is, how do we pack it? And we're going to, remember, we're going to skip the MZ header. So the DLL, which is actually the assembly, we're going to say patch the length of the assembly into the assembly header. Because I don't think this is going to cause issues, but it may do. It may do. So we will skip the MZ part of, oh, can't type, part of the header. I know that comment's kind of hard to read based on the color scheme. Sorry about that. And so what we're going to do is we'll start with 2. And we know, because it's going to be a 32-bit integer, we're going to pass in 4 bytes. Okay, so from position 2 up to and including 4 bytes, so up to position 6, we're going to patch in the value of the length, which is going to be assembly.length, but we need to pack that. .pack as a length. So bearing in mind, when we pulled the length down as part of our stager, right, you see that we read a plain old int32, okay? And the reason why that's an int32 is because it's packed on the wire with V rather than N, so we didn't have to do anything magic with like little endians or anything like that. So it's not part of a TLV packet. So this should mean that we should poke the actual length of the assembly into the 3rd byte onwards. Okay, so what this means from the other side as part of our stager, right? We read the length of, it's actually not metsrv. We're going to call it full stage size is read int 32, okay? Then we're going to have what is effectively going to be the buffer that contains the whole image that we're looking to read in, okay? Yay, perfect. Watch. Oh, excellent. Thanks, Barney. It makes me happy knowing that at the other end of the internet you're sitting there with your pants down. What a wonderful image. Okay, so what we want to do is we've read the full stage size. We know that that's going to contain the whole thing. But what we do know is our MZ header is coming next. r.read bytes 2, first 2 bytes. Var, what is it going to be? Metsrv length size. Sorry, metsrv size is going to be r dot. Now, one of the pains that I've got here is we don't have the ability to sort of pull everything in off the current stream in one go. Well, actually, we do. The problem is that we would read the entire configuration into memory, and then we would have to create another reader from the config. And you know what? That probably makes more sense. I think I might do that. So let's read the entire stage in. Okay, var full stage equals r.read bytes full stage size. And we've got to put everything in memory anyway. Okay. And then what we can do at this point is we can create a configuration reader based on what gets spat out the other side. Okay, so if we go like this, so we want metsrv length is going to be the full stage offsetted by 2, right? Now, the question here too that I would like to know, and I'm going to play with this in just a minute once we've actually got some stuff moving back and forth, is if we say assembly load from a block of memory that contains config at the end, is it going to buff? I don't think it will. Which means we probably don't need to split things up into chunks and handle them separately. We can just have effectively a single reader over it, right? So if we did this, we'll go using var memstream equals new memory stream. If I could type that out, memory stream full stage. Then if we did equals new binary reader memstream, then in here what we can do is go right, skip over the MZ header. So memreader.read bytes 2. So we can skip the MZ header. 9 bars is better than 1. Okay, read in the length of metsrv. So var metsrv size equals memreader.read int 32. And that should be enough. So now we've actually got the size and we've skipped over everything else, right? So what we can do, because we know that behind the scenes we're dealing with a memory stream, we can actually seek to the end. Okay? Let's just comment that out. Putting a disclaimer out before the following is written, you'll have to use your parent reading skills. Oh dear, that sounds terrible. Point the reader to the configuration. Okay, so we end up with we want to skip we want to go memreader.seek, no, basestream.seek. So we're going to seek from the start of the stream. So What is it going to be? It's going to be metsrv size, and we're going to do that from the start. Okay. So that will point everything up to the beginning of the configuration. Okay. And once we've done that, we then need to go, right, let's go var asm. What we might do even at this top level is go var appdomain equals appdomain.createDomain. Now you can give these all kinds of crazy parameters and, you know, appdomain setups and policies and blah, blah, blah. But we're going to, just for the sake of this, we're going to call this the Meterpreter host. Now the reason I'm doing this is for debugging purposes, not because this isn't something that we're going to end up deploying, okay? This is just so that when we're analyzing what's going on in memory, we can look at the name of the current app domain and see where we are, okay? Exploit dev in C#. No, we're building a payload in C#. New version of Meterpreter in C#. Okay, so then I want to go app domain dot, what's the word? I want to not create instance. We want to load, don't we? Appdomain.load. We can give it an assembly or we can give it bytes. Now the bytes I'm going to give it are the full stage. Okay, and I'm going to hope that that just magically works. Okay. If we need to snip the configuration off the end, we'll do that afterwards, but I don't think it's worth going through the pain of that up front if it just magically works, right? So now what we need to do is we need to create an instance of Meterpreter. Okay, there's a number of different ways that we can do that, but we need to do that without knowing anything about the type at compile time. This is where reflection is going to come in and be nasty. Hey Barney, I'm doing great, buddy. How are you? Okay, so in order to do this, now we've loaded the assembly. We hope. And then we need to go and reference a type. Now, if we have a look at what we've got here, the server. Okay. What we actually would be better off doing here is having a bit of a bootstrapper that's static, which is much easier to call. Okay. So here we've got this, server. We can create a new instance. We want to create a new instance without specifying the type. Yeah. Meterpreter lacks functionality. And you're already developing a new one. You're entitled to your opinion. So, I'm going to create a static factory sort of method that will wrap some of this stuff up for us. Okay. So public static, and this is going to be void, and we're going to go. We're going to call it create. Or should we say bootstrap? We're going to bootstrap it from the reference to binary reader. What I love about opinions like that, Wormare, is that it's very, very easy to be the critic of a piece of software, particularly when it's free. And name a payload that basically provides what Meterpreter provides for nothing, that's open source and is updated as often as this one is. I'd argue that you're not going to find many better options. And it does continue to evolve. You're seeing an evolution on screen now. But look, it is what it is. So, your call. Righto, so what we're going to do is we're going to basically do exactly what we did here. Oh, actually we can't, can we? Yeah, we need to do some overloads. We need to do the binary reader and the TCP client. So if we get one where the TCP client's specified, then we can use it, and we'll do another overload another time. Hey null mode, welcome to you, sir. Thanks for coming in, mate. And then what we can do, cases where we don't have a TCP client, such as when we're dealing with HTTP transports, we can just call run. Okay. We might even rename this to make it really obvious, but I don't think I will. We'll just deal with the overloads. Now, what we want to be able to do is we want to we want to create we want to get a reference to this type. Okay, now the type is met.core.server, right? Hey Will, I'm doing very well, buddy. How are you? Little climbing mate Will's back on again. Okay, so that should give us the assembly. I can't type tonight. Assembly. Now if we call assembly.getType met.core.server, as we can see just a little bit lower. Hard refresh, hey? That's a bit crap. So that's the type. And then once we've got a reference to that type, I want to get a reference to a static method on that type. And then I want to invoke... Actually, maybe doing the static thing isn't going to be that helpful. Because if we go assembly... Maybe not even assembly. app-domain.create create instance. Assembly name, type name. It'll have an overload, right? We can give it a type. Well, there's no point in giving it a type or even extracting the type if they're not going to get used. But geez, have a look at this. Assembly name, type name, ignore case, binding flags, binder, and arc. So what we're going to do is I'm going to look to find some references to this because I don't want to go and figure things out straight from the API. It's been a long time since I've done this. And what I need to think about here is what does it mean? Oh, actually, you know what? I might be making things harder for myself to begin with just by using this create domain stuff. So perhaps maybe what we should just do is this. We won't worry about the app domain thing yet. We'll worry about that another time. Okay. So if we can go type.get method. We want to get a method. The name of the method, the easy option would be to rename it. Bootstrap TCP, but I'm not going to do that. We're going to call it Bootstrap. Binding flags dot. Okay, so it's going to be a get. Where are we? It's going to be public. It's going to be a public static method. Specifies that a method is to be invoked. This must not be a constructor or type initializer. That's okay. I don't think that's what we want though, right? We just want, we already said that declared default exact binding flatten hierarchy get field. I think that's pretty much all we need. Public and static. And we'll leave everything else for now until it bites us in the butt. Parameter searches for specific parameters match the specified argument types and modifiers. Okay, cool. So let's go with arg types equals new parameter. What was it? Parameter modifier. We know we're going to have two of them. Okay, so new parameter modifier. What do we give it? Initialize new instance of that structure representing the specified number of parameters. Is that it? We know that we want two, but this said match the specified argument types and modifiers. Maybe there's a couple of static methods. No, there isn't. Has anyone used these before? Let's just see if there's any like public fields that we can set on here. Aha, here we go. New. Is this what we want? Give me a second. Okay, so there's no public properties that I can set. Let's check the documentation. Okay, so .NET C# parameter modifier example. Let's have a look. Oh, it's a struct. That might be why. Get method import passing parameters. Let's see what this says. The following code example shows this, remember, as 3 string arguments, first third of which are passed by reference. Okay, so parameter modifier is, there's 3. Okay, so we end up with pass the first and third parameters by reference. Oh, is that what that does? The parameter modifier must be passed as a single element. Invoke the method lateBound. Okay, so we don't even need to search for the method. We can just invoke the method. Bootstrap. Let's copy that so that we don't have to do it again. So the binding flags invoke method. Oh, we don't even need to do that. Public static binding flags invoke method. And so the passing in null for the binder. The target object was going to be static, so we don't actually want null. Sorry, we don't want to pass anything in because we've got null. And here we just need to pass in the arguments. So maybe we don't actually need... We don't need the parameter modifiers if we're not doing anything with the parameters, perhaps. Maybe that's what that means. Which rings a bell, to be honest. Am I a pro at Rocket League? Oh, I wish I was a pro. I love that game, but I'm nowhere near that good. Okay, so the args will be a new object. And we're passing in 2 things. We're going to pass in the... where are we? The mem reader and the TCP client. Like so. Why reflection over met.core.server.bootstrap? Because remember, we don't want to know anything about the types in our stager. So a stager could be an ASPX, it could be an executable, it could be any of those things. But we don't have a reference to metsrv in our current CLR instance or app domain. So here is where we're actually loading it on the fly, and then we've got to get the type out of what we've just loaded, and then we've got to invoke it. Yeah, no worries. I thought you knew that. I know you know that already, Smash. Capmap, thank you for the follow, my friend. I appreciate that. So yeah, this is going to be effectively what our stager will look like at the time. So that's basically where we want to get to. Now, what I am going to do, just for the sake of making it so that it's obvious that we've got to a certain point with our transport, is I'm going to put something directly into the metsrv server in the run function. So that when we've done everything, when we hit the run function, I'm basically going to break or write a file or something along those lines, because we're going to be operating blind once we've got the staging process sorted out. Okay. Righto, so with that piece of code kind of butchered, but this is effectively what a stager may look like at some point, okay? These will be hard-coded values. And then, you know, if we're dealing with HTTP down the track, we will just only pass one single value in, okay? Righto, so let's just build that and make sure it compiles. Success. All right, let's go back over here. So now I think we've got this down, right? One thing that we don't need is this payload windows. Righto. So we're going to be calling this payload windows. We're going to call this CLR Meterpreter loader. Stub for this will be Arch CLR payloads. Okay, Rex payloads Meterpreter config. We don't need the reflective DLL loader. Okay, so there is something that we're going to do here, isn't it? I mean, I guess for now it's not going to be that big a deal, but we really should. Yeah, no, I'm not going to worry about this either. So obviously need to change this down the track. But for now, we're just going to pretend that we're operating within the context of x86 so that we don't have to put too much wiring in place. Okay? Does it suck that I'm sending you a present tomorrow and you have no way to stop it? Yeah. Yes, it does. Thank you for that. Okay, so this is a very rudimentary stager, so to speak, or I should say Meterpreter loader. Who have we got now? Ritko, thank you for the follow. I appreciate that. So this MSF payload Windows is sort of part of the parent. So if you have a look over here, you'll see that there's in the Windows folder. Where are we? No, sorry, not Windows folder. LS. Which one are we in? Yeah, right. So we go payload Windows.rb. So if we have a look at that, you'll see there's a bunch of other nonsense in here. Okay. But we are going to need something along these lines for our CLR stuff, but for now it's going to remain pretty empty. Okay, so let's just copy Windows.rb to the same folder. We're going to go CLR.rb and then we're going to edit CLR.rb. Righto, so we don't need this. We don't need any of this, or this, or this. What we do need is this one here. We're going to change this, obviously, to CLR. I'm not going to worry about exit types for now. We're not going to do anything with prepends. So this is all us trying to wire our existing, I should say, the new stuff into effectively what all of this stuff means. So I guess what I'm trying to say there is that we've got this new world that has different architectures and platforms and all that sort of stuff. And we're going to try and wire in something in here that makes sense. So that we can still live within the realms of the way Metasploit wiring actually works without sort of carrying too much baggage. Okay. So I'm going to get rid of this. So what does it say? This mixin is changed within payloads that target the Windows platform. We're going to go CLR. It provides special variable substitution for things like CLR version and automatically adds the required option of exploits to use Windows payloads. We will get rid of that. Okay. Now, what is this? Alias equals A. We don't need to worry about any of that nonsense. Well, what we probably will have is this opt-enum new CLR version of the CLR to target. It's not going to be processed. We're going to default to net35. Okay. But the types will be, hang on, let me just quickly check what format that was in. Types. It can be either. I'll probably just make it a clean array. Let's go back to where we were. And so that's going to be net. I don't need the dot in there, do I? Net 35 and net 40. Okay. There's a bit of discussion going on. Meterpreter and Metasploit works only in a lab environment. Okay. Yeah, right. Okay. There's some commentary around whether or not it's a possible to use Metasploit on a real gig. Look, we're not gonna dive into that now. That's just, you know, to be honest, it's a bit of nonsense. If you can't use it outside of a lab environment, mate, then that's cool. I don't have that problem. By the way, so see this line here on line 32? You're supposed to reference the superclass, I think. That's not needed anymore. It's inferred, so we can get rid of that. Replace var. Now I don't think that's... Oh, is that invoked outside? So we don't need to do anything here. I'm just going to return false. Actually, no, I'm going to get rid of it completely. Handle intermediate stage. We don't have an intermediate stage, so I'm going to blast this away. Okay. I'm not going to do this. Send UID is false. Okay, so I'll talk about UUIDs another time, okay? And that should hopefully be enough as far as getting a payload. What is an intermediate stage? Okay, so in certain exploits, I think, and certain scenarios, there's a case where you can only sort of upload a bit of something. So it's like an intermediate bootstrapper. I can't think of a time when that's actually been used by me in any scenario. So I can't really give you a use case where that's actually appeared, but what I can say is like, yeah, exactly. So you end up with the exploit, and the exploit might only allow you to read in X bytes. And the stager for a particular thing might be too big. So your intermediate stager might be a lot smaller. And so the intermediate stager lets you do just a little bit more. And then from there you kind of get bigger and bigger and bigger. It could be, yeah, it could be that. It could be anything. But I've never really dived into what the implementation of that is. Like if you have a look here, you can see. Actually, let's have a look at what this one says. For Windows, we check to see if the stages being sent is larger than a certain size. If it is, we transmit another stager that will ensure the entire stage is read in. So there you go. So if something requires a mid-stager, then we basically have this mid-stager block, which is much smaller than a standard stager from the Meterpreter. Okay? And so that's what's invoked, and then after the fact, you'll end up with... So you can see here we've got this com.put mid-stager, so it puts the mid-stager first, and then it assumes, once that's been run, that it will read in the rest as you would expect, and off it goes. Alright, so for now, this is all I'm going to do because I do want CLR version to be here. That's going to be part of all of the areas that require the use of the CLR. So let's change this back to CLR. Okay. This class is here to implement advanced variable substitution for CLR-based payloads, such as CLR version. Okay, let's just leave it as that. So this is a nice cut down, simple thing. Let me just quickly see what that apply prepends did. If it returns something, I should probably look to do the same. Apply prepend migrate. Is that in here? Ag apply prepend migrate. Oh, it's what am I doing? Can I specify a location for ag? I can never remember. Ah, gotta do it afterwards. Def. It's so it's in prepend migrate. Okay, so yeah. Alright, let's have a quick look at what this contains. Jeez. I remember writing this. This has got my smell all over it. Jesus, look at that. Yeah, that's significant, isn't it? So here we go, it does return something. So we're just going to return whatever we got given. I think that's probably the best option there. Some OJ stank. Yeah, amen to that, brother. Terrible. So I'm just going to return raw. Okay, so whatever it is that we got, we're just giving it straight back. In Vim. Okay, so with that out of the way, we are going to need to create... What's funny, isn't it? If we've got the CLR version in here defaulting, then we should be able to read that in here as part of this. So we've got the opts, which should contain the data store. Okay, so we should be able to go DS CLR version. That should work. You need my Vim setup. It's up on the tubes, my friend. I will provide a link. And have a look at my Vim live stream where I go through Vim at some depth. That's probably got the reference in it as well. Smash, man. I know the feeling. The reason why I can say this has got my smell all over it is because I remember writing these extensive comments and doing various other bits and pieces, and yeah, I can just tell that I had a part to play in that whole shenanigans. Plus, yeah, anyway, I'll stop there. And there's, check out the Vim Vice color scheme. Okay, really interesting. Oh, you want to git blame it? I don't know. Hang on. Tab Assassin saved my bacon, but as you can see, I do have snippets in here. HDM. It looks like Tab Assassin is saving my bacon here, but look, there's me. I am definitely in here. Yeah, there's too much evidence. Sorry. I know it's terrible. Hey Mugi, thanks for sharing that link, mate. Okay, so now there's other wiring that I know needs to exist in this, but I don't remember what it is, so we're just going to have to wing it. Okay, so let's close that down for a minute, and we will go back up to... Where are we? We're in lib still. So let's go to modules, payloads. So we've got singles, stages, and stages. We've got a single is basically the stageless versions, things that will run all by themselves. We've got stages. Oops. So that's what takes, you know how you've got your Windows Meterpreter reverse TCP. That basically says platform, payload, transport. And that's how that works. Okay, so ignoring the platform for now because we're going to have CLR. The payload will be Meterpreter, so Windows Meterpreter, for example. So we're going to have CLR Meterpreter something or other. And reverse TCP references the stager. But that's also where it gets information about the listener from. Okay, so I'm going to go and make dir CLR. And let's just have a look at what's in the Windows folder. So you can see we've got DLL inject, which we're not going to do yet. We've got Meterpreter, which we are, and then there's shell and patch up and blah, blah, blah. So I'm hoping that when we do this, and this actually gets to a point where it's usable, that we will end up in a situation where people will go, you know what, I can create a shell, a CLR version of a shell payload. So it's not Meterpreter, it's a shell, and they can use what we've done here to go and put other bits and pieces in. Okay. So let's take a copy of the Windows Meterpreter thing, shove it in here, and open it up. What have we got? Windows Meterpreter. Nope. CLR Meterpreter. We'll say via, we'll go assembly load. Interpreter options, we're going to need payload CLR. MSF license sessions Meterpreter. So we've got x86 win here, and we're going to have, I'm going to keep x86 in there for now, but I'm going to put CLR in like that. I'm going to get rid of the convention because, oops, I'm going to get rid of the convention because that's not relevant here. Get rid of the famous escape and the famous Stephen Fewer. Inject the Meterpreter server DLL via assembly loading. Load into the currently running CLR instance. Okay. And that's pretty much all we need. So injects the Meterpreter server DLL via assembly load. Kind of don't need these comments. They don't get read, and we've got the stuff in the description along with the transport related configuration. So that should be enough. But what that shows is that we actually need to have a special session that is specific to Meterpreter CLR. No, I don't need those requires. I'm about to get rid of these. I'm going to change that to CLR. Meterpreter options we definitely need, and we're going to change this Windows to CLR. Okay. So now we're pointing to all the things. We still need the Meterpreter options because there's Meterpreter specific stuff in there that we need to include in our payload. But what that has shown us is that there are other things that we need. So let's go into... where are we? Go up to... Okay, so we're in stages, payloads, modules, lib, MSF, base, sessions. Alright, let's close this off. So you can see we've got all of the things in here. So we're going to take a copy of the x86 Windows one, and we're just going to make a CLR version of it. Now the x86 is probably going to change to nothing, maybe? Don't know. We'll see. Probably just be CLR. Oh, actually, hang on. We said that it was going to be Windows and CLR was the architecture. So we need to change that. Let's move that to... CLR win. Does that mean... Barney, thank you for the gift, mate. I'm sure Smash will be upset about the fact that he has to rock up as much now. Hey, Dean's here. Thanks for coming on, mate. So what did we say? Well, I said the CLR is going to be the architecture, but the problem with having the CLR as the architecture is that it's actually not the architecture, it's kind of the host. The architecture can still be x86. So you know what, I'm not going to do that. Oh, wow. Man, stop dishing out the gifts. Thank you, Barney. That's very kind of you, mate. Yeah, I'm going to keep it as x86 for now because... we'll need to revisit this when we figure out how we're going to handle things like platform and architecture. Oh man, he's giving another one out to null mode. Someone stop him. Very kind of you guys. Barney, you're spoiling me, man. Please stop. It's very nice. Okay, so let's open this up. x86 CLR. Now, we do need to think about this a little bit more. So the base platform is going to be Windows. Let's have a look. So now I'm going to get rid of this Windows error thing. And I'll get into the reasons why we're doing that a bit later on. Interpret x86 CLR. Because the thing is, remember, we could have a 64-bit version of the CLR. We could have a 32-bit version of the CLR. So there's still an architecture under the hood. So, but generally when we compile a CLR binary, we just specify any CPU, and it shouldn't actually matter whether we're running x86 or x64. So this is a discussion that we're going to have down the track. Oh my! Ladies and gentlemen, we have the presence of greatness among us. The one and only Benjamin Delpy has appeared on stream and said hello. Just landed here and I don't see any Get System Anonymous Kiwi is deployed. It's lovely to see you, Ben. Thanks for coming in, mate. And thank you for the trolls. Get System trolls from Ben Delpy. Doesn't get much better than that, hey? Hands up if you love a bit of Mimikatz. Shine your praise onto Ben. Thanks, Ben. I'm stoked to see you on stream, my friend. It's been too long since we caught up. We need to get together face to face again and have a coffee and a chat. It's been way too long. Now everyone's going off. See what you do, Ben? You come on stream and everyone's cheering and going bonkers. It's wonderful. All right, so we're going to leave that for now. Yeah, I should just type my creds on screen. Hey, I'm new to the stream as well. One of the Binary Ninja devs. Ah, really? Does that mean that is it Cerulean? Is it Cerulean? You've been following Cerulean? You guys are funny. Man, Barney's still giving out the subs. Cool, man. Well, thanks very much for coming along. Obviously, I'm showing something that's significantly different to the magic work that Cerulean does with Binary Ninja on stream. He's pretty wicked. So he's a good lad to follow along with as well. All right, so I'm going to leave that for now. We're going to stick with... see, this base platform is Windows. But the art is going to be CLR, so you know what, I am going to have to change it. It's going to have to be CLR Win. That's what it's going to have to be. So let's move that to CLR Win. I think that's going to have to make the most sense. Barney, man, you're going bonkers with these subs. Haven't done much exploit coding in a while. First one was bang exploits to CVPN. Yeah, wow. Man, yeah, definitely check out Cerulean's stream. He is a binger wizard, a definite binger wizard. Man, Eric's going bonkers now with the bits, the usage of the bits. Yeah, Cerulean's stream is awesome. Bit of assumed knowledge, man. The dude knows his stuff when it comes to binger. Righto. So with that out of the way, let's go back to. Never remember how deep I am, so let's go to modules, payloads. Did we go, was it stages we went to? I think it was stages. No, yes. So we had CLR Windows, right? 37 watch is certainly not doing badly on that front as well. Yeah, absolutely. Yeah, man, I'm gonna get system emote going. Don't you worry. All right, so here's an interesting little world that we're in right now, because in Windows land, all of this stuff here by default is x86, and then there's this x64 version here. So do we take our CLR stuff and put it under Windows? Probably should, but then we're going to end up in a different world of hurt. So yeah, let's do that. Let's move CLR into here. I think that makes sense. We had another follow there, have we? James Gamer. Is it Gamer or Gun? Yes, Gamer. Thank you for the follow. We're coding up a C# implementation of Meterpreter, mate, to run on different versions of the CLR. That's basically what we're looking to do. So let's open this up again and just quickly change this to CLR win. And this, oops, this needs to be CLR win as well. Now, did we change that correctly? Oops. This one here, sorry, I'm just looking at this for a sec. Just want to make sure that I've done it. Yeah, it is capitalized, okay. So that's okay. Platform, like I said, we're going to remove the base arch at some point. Firefart's come along and he's subbed. Thank you very much, man. You're a legend. The Lame Beers has also followed. Thanks for the follow, mate. It's all happening. Man, I can't keep up. It is 9:05 and the chat's going nuts. Finally give you my Twitch. Thanks, man. That's really kind of you. Righto. So with that out of the way, once we've got the session stuff done, we need a stager. So let's go and into stages. So here we go. We've got this reverse TCP thing that we're going to need. So let's make dr CLR and we'll copy reverse TCP.rb into CLR. Yeah, let me just change this for a minute and then we'll go gvim CLR. There we go. Opens up on the side. Okay. Reverse TCP stager. Platform win. So all of these things are effectively going to be the same. Requires mid stager equals false. Now cache size is something that we're going to have to muck with later on. But MSF payload. Let me just check something. Can x64 reverse TCP dot RB. So what does this do here? Arch64. It's still handle reverse TCP. Ah, that's what it does. So maybe because we're in this LAN, we need to put this here. Handle still reverse TCP. Connect back to the attacker. Windows CLR. Payload stager. Yeah, the case, that's definitely going to change. Core payload windows, I'm going to have to change that to CLR reverse TCP. Core payload windows, CLR reverse TCP, yep. You should do sub-drives so you're privileged to get named as a co-author. That's a pretty funny idea. Paying too much attention to the chat instead of actual stream content. Yeah, me too. Use my Twitch Prime sub and I don't know if this is faux pas, not gaming streams. Ah, man. Thank you very much for that. Yeah, that's hilarious. Nothing is faux pas when done in good humor. So I very much appreciate that. Thank you. Alright, so that means that I'm going to have to go back to... Where are we? Stage, Windows CLR, Payload CLR. So we're going to need to go to this. So I'm going to move CLR into Windows because let's see, there's a lot of window. I'm scared I'm kind of blending things together when I don't really want to be. I think I might actually have to keep this outside because it's not really a Windows thing in this particular instance. With this could cause us all kinds of grief. Anyway, let's just go back to the stager. Okay. Righto, so we didn't have anything magic in there, so that's all fine. Payload Windows CLR reverse. I guess it doesn't matter, does it? It's not like we're implicitly... Yeah. Let's leave it like that. So this is a little bit of a hodgepodge, but we're going to have to figure this out a little bit more down the track. We'll see how we go anyway. Can we send you shirts for streaming? And yeah, you can do that if you like. Maybe reverse it when I get allowed and name blame somebody else. Yeah, that's a fair point, Atwolf. That is a fair point, mate. Now, I'm not going to worry about singles. So what I'm going to do, though, is I need to figure out where the actual stager payload lives. I'm pretty sure that is going to be in... Got modules, payloads, stages. We've got libmsf core payload CLR. Let me go back. Oh, we're actually here. So if we look at reverse tcp.rb, you see we're including, what are we including? Handler and payload. But the actual payload itself comes from this and this. That's right, so we need to create whatever it is that we're doing there. This is pretty messy. So what did we say we had? Payload Windows reverse TCP underscore CLR, which was in CLR. You know what? We don't actually need to do this. Given that this is just a namespacing thing, I'm going to do it that way. So this payload CLR reverse TCP comes from here. We just need to make sure that that matches. So that would be... Nope. Right, okay, so in Windows, there's the reverse tcp.rb here, right? There it is. Okay, here we go. We're making progress. So we need to move into this folder. Okay, let's go into the CLR, and we're going to take a copy of Windows reverse tcp.rb and put it locally. Okay, payload CLR reverse TCP. Reverse TCP. Righto, so we need the transport config. We don't need any of these ones though. Reverse TCP generation of Windows. That'll change down the track. Don't want any of these. We want payload CLR. Opstring payload bind port. Register TCP specific options. Okay, we can leave that. We can leave all of these things the same. Generate reverse TCP. Include SenuID false transport config. Generate reverse TCP. Okay, so here's where we actually generate the stage. Okay. Now this is where it's actually going to get fun, because when we generate the stager. So when we generate the stager, as you can see, there's a lot of assembly here in... Where are I? Let me just get rid of all of this. So this is the native stager, right? Which we don't need pretty much all of it for. What I'm going to do here for now is I'm just going to go and return. This is where the stager payload goes. So we can see that when it comes out, right? Is that another follow? Dark Tower Builder has followed. Thank you for the follow. Man, you guys are loving the chats tonight. Okay, so with that in mind, it means that when we generate a reverse TCP payload for the CLR reverse TCP, it's basically going to spit out this hard-coded piece of text. Okay. There's a lot more magic that needs to go in. We don't know what these things are going to be, and I'll talk about what the required sizes are down the track. They probably, in the case of these payloads, are going to be fixed size. You're just trying to make me pretty. Don't make me pretty. I'm quite happy unpretty. Okay, so with that sorted out, so we've got a basic stager for reverse TCP. We've got a basic stager for, basic payload, and we have the ability to load certain things off disk. Okay. Now, what I need to do. I'm going to take a copy of that contain folder. So Meterpreter bin debug. This is the DLL. So I'm going to leave that window open, create a new one. Stream. We can get rid of these. And I'm just going to drop metsrv net35 in there. So if we go to where are we? Let's go to a new window. CD code Metasploit framework data Meterpreter, and let's move scratch stream CLR Meterpreter to here. Okay. Let's go, and now what I want to do is I want to see if I can generate something. And all I'm going to do for now is I'm just going to type msrv venom list payloads and see what it does. Need to put that back to 4.2. Give me a minute while I bundle install on stream, because that's always fun. Thankfully this doesn't take too long. So what I'm trying to do now is, like, there's a lot of mystical wiring that I don't fully understand, and I won't be able to get it working until I start fighting against the errors that it spits out. But Venom should, like, when we actually get this working, we have the right stager and we have the right this and the right that and whatever, then Venom should be able to spit out the payload as something that we have created. So the question is it going to spit out CLR command windows? So we should see it somewhere in here, right? I assume. And there'll be an error somewhere. I'm just going to figure out where it is. This is the bit that becomes more painful. Oh, and by the way, I am going to have to stop in 15 minutes by 9:30 because I have some other work-related things that I really need to do. I apologize for that, but duty calls, as I'm sure you guys are fully aware. Okay, so it was Windows CLR, wasn't it? Payload stages, Windows CLR. D Windows add user. So I would expect it possibly to be in here. And this is one of the areas that's really confusing, right? Because I can't remember how and why things would appear in here. But let's go with, let's see if we go msrv venom -p Windows CLR Meterpreter reverse TCP. Let's just see if it should just basically go, I don't know what that payload is. There you go, invalid payload selected. Pipe grep CLR, view Ruby, hooray for Ruby. No, none of those things. Work related things. Oh, here's Archbishop. Thanks for coming along, mate. What is that? Ah, you're the bits. Okay. So yeah, we've got Windows. Currently we're specifying Windows CLR Meterpreter reverse TCP, which is pretty much where it lives according to this. But I've got to figure out where the logs are. Where are the logs? Oh yeah, tail-f. Where are we? I think it's framework.log. Okay, let's see what happens here. It's going to be a lot of noise popping out here, I think. Yep. So this is where the magic is. let's start from here. Okay, so we're loading CLR Meterpreter RB. It failed to load due to the following error. Name error, uninitialized constant MSF payload CLR. Okay, so that's handy to know. So let's go back to, where are we? Payload CLR, so MSF payload CLR reverse TCP. Include payload CLR. Now it was, the exact error came from here. Alright. So let's open this up. MSF core payload. Did we move it? So we put it in MSF core payload CLR Meterpreter loader. So that was fine. Oops. Failed to load the file name error, size constant, blah. Call stack, Meterpreter loader, line 14. That makes no sense. Oh no, it wouldn't be that. See how hard this stuff is to read? It's terrible. Core Meterpreter failed to load because it tried to load MSF payload CLR. Call stack Meterpreter loader. Okay, so let's load this one up again. Sorry about this. This is one of the worst parts of doing this stuff. Yeah, right. So that should be payload CLR. And we need to include code, metasploit, framework, lib, MSF core payload, Windows, Meterpreter loader.rb. What were the includes? That's not right. Yes, it is right. Let's close that, and that definitely needs to stay as is. Let's go back over to our other one. Do it again. Rage Master, hello. No, I'm not programming a module for it at the moment. I'm trying to build a whole new payload for it, as Smashery is currently mentioning. Far out, this is so hard to read. Meterpreter failed to load because it's loading in Meterpreter loader. Uninitialized constant in the loader. Core payload Meterpreter loaded. Top required. Okay. So it looks like the root cause of the problem is inside the Meterpreter loader, right? I think that's fair to say. So it's looking for payload CLR. Maybe what I need to do is add MSF core payload CLR. It's pretty horrid. The Lambeers, man, I tell you what, you must be. Oh, that's pretty interesting. We're going to come back to that in a sec. Look, we actually got where the payload got generated, even though it's terrible. So have a look at this. The Lambeers, you just said that you started on Slackware in 96. I started on Slackware in 97. Man, we must be a very similar age. Either that or you started a lot earlier than me. Anyway, that's cool. We didn't see any barfing. But the problem here is choosing MSF module platform Windows, which I guess is what we want. So here's the thing. Hey, Archbishop, your messages has been temporarily suspended because of your foul language, my friend. I do actually have that book somewhere. It might even be on the shelf behind me. Yeah, the Slackware Unleashed book, man. That is a tomb. Or tome, I should say. Not a tomb. Tome. Anyway, I'm excited because as you can see here, it's generated exactly what we want. So this should mean... There you go. That's better, Archbishop. This should mean that we should be able to go MSF... Let's go MSF. What am I? Console. Use multi-handler. We're going to go set payload. What was it? Windows CLR Meterpreter reverse TCP. Set lhost 192.168.20.171. Set lport 4444. Set exit on session false run-j. Man, I remember those days, hey. Yeah, I agree. I had an ET6000 video card back then. Ooh. Check this out. Windows CLR Meterpreter reverse TCP listening here. How exciting is this? Okay, so now this is cool. Because if we run this and we are actually able to connect, hopefully it will actually pick up the DLL off disk that we've told it to pick up based on the config. Oh, actually here's a config thing. We should check to see if it's in the configuration. Look at that. CLR version is in there and everything. Oh, it's so good. Who's excited? I'm excited. It's good to see progress like this, don't you think? Alright, let's run this. Let's run this bad boy. And see what happens. Oh, I've actually got a simple TCP stage test. Alright, here we go. Here we go. 2 minutes. Yeah, I know. Come on. Build started. Alright, let's see. Connect. Ooh, what happened? Did we get it? Did we get something? It's connected. Get stream. Read. Now, notice that we haven't got like a sending stage message because I think we probably removed it. But let's see what happens. So the full stage size, I'm sitting there hanging. Aha, so clearly it's open to socket, but it's not doing what we need it to do. So let's just quickly check. Netstat dash ANTP pipe rep. Ah, check this out. So we did have a connection from me. Isn't that interesting? So clearly what's happening is we're missing some wiring that actually says we want this stager to go in. We just need to figure out why that's the case. So maybe what we'll do at this point, just quickly, maybe it's because what we've got is we're kind of still conflating this with Windows. Maybe that's the problem, is that because we're still referring to this as like a Windowsy platform, which we still need to do because like we have Python on Windows and PHP on OS X and, you know, blah, blah, blah. We still need Windows as in like it's the host. Arrowway. Wow, there's a name I haven't seen for a while. Welcome, mate. We're just about to wrap things up, so your timing is impeccable. Oh, hang on. So we don't actually need this reflective DLL loader, for one. That could be part of the problem. Alright, so what I'm going to do is I just want to make sure... did we get here? I'm going to put some crappy printf debugging in here. And let's see what happens. Let's go NC to ourselves just to see what it does. Now that will always fire the first time, but aha, so we do get here, which is pretty exciting. So that means we are returning stage Meterpreter ops generate config. Now, oh, you know what this could mean? It could mean that something is breaking. So how about we do this? We'll go met equals that. Comment that out. Met equals that. Conf equals that. And we're going to go return met plus conf. And I'm just going to put this in. Actually, we'll leave that there and we'll go generated met. Met.length bytes. Generated config conf.length. Good old printf debugging is all that we've got. Hey, Arroway, thanks for the follow, mate. Let's see what happens when we try this again. Come on, come on, I can't leave it hanging. We're so close. Did we get here? Ah, so generation of our metsrv payload actually failed. Hooray for printf debugging. Let's go back over here. So that means something in the stage Meterpreter failed. I wonder if it's this. Let's take a copy of that. So let's go. About to read metsrv assembly. Ah, check this out. There's an actual failure right there. Returning the metsrv assembly. Let's go back here. We're so close. We're so close. Lemon Android, hello. Come on. About to read metsrv assembly. Okay, so that's failing, which is really interesting because CD. Oh, hey, maybe it actually needs to know about that file, but it should. Split framework. Data Meterpreter. So we can see metsrv net35.dll. That should be about to. So we'll go name equals metasploit. We've got some crazy tunes going on here. It's going to be... This is a really weird song. Why is that unhappy? Assigned but unused. About to read assembly. Man, this is bizarre. This. Let's try. Come on, come on. So close. We've got to see something go across the wire before we go. Can't come this far. That's not happy, hey? Why is that not happy? So we got here, and we're calling stage Meterpreter. So this DS-CLR version, let's put .inspect. because clearly it's not happy. This is such bad music. I'm going to leave it running, but I don't condone it, just so you know. Man, there is something seriously wrong going on here. So it's got to have something to do with this CLR version stuff that's going on, right? How about we do this? Let's leave that. We've just had another follow. Thank you, whoever that is. Let's go. I'm going to go ds.inspect. So here you can see why I do this stuff on the command line all the time, because a lot of the core stuff that we're reloading effectively needs MSF to be completely reloaded. And it makes it so much easier to restart. Man, it's really not happy. I don't know why. Because that inspect call that spits out the standard error, that should just work. Oh, hang on, what? Can you see it? Because I can. There it is. So ops is what's being passed in. And so what I should do, I'm going to leave that as DS because that needs to go away. And we need to basically do the same thing as we do here. What a fail. DS CLR version .dll. Man, you guys, where were my wingmen? That's a perfect use of that. Yeah, those things. OJ fail. That's a very good idea. Let's do that. Returning the metsrv assembly. Oh, how exciting! Check it out. That's so cool. Okay, so if that's the case, where else are we failing next? So we weren't returning the metsrv assembly. DLL packed. So there's something else that's clearly not working. Because this assembly is clearly not behaving as we want it to. Assembly.inspect. See how it says returning the metsrv assembly? But we went searching for the assembly ds whatever. I didn't see that happen, did you? Why are we not seeing this error? Why are we not seeing this? I think I've had another couple of follows. Thank you for whoever that is. Aaron Q7, Lemon Android, thank you for the follows. ds.inspect. Yeah, there's a lot of people who have followed, which is really nice. Come on. Oh, here we go. Let's see. Right, so searching for the assembly net 5. Okay, so that did come through. That's fantastic. Returning the metsrv assembly home as float data meterpreter metsrv.net. That's exactly what we want. Okay, returning the metsrv assembly. So we got Ah, that's our problem, because that generates the path. So now we actually need to load the file from disk. Bingo. This is the kicker. Okay, so if we just go up to the Python Meterpreter loader, we should be able to see what it does to load the file, just so to make sure that we load things correctly. So met equals met payloads read. Boom. That may well be it. Come on, so close. Ooh, it's buffed. Yeah, I got ahead of myself. Bummer. Let's go dot puts red assembly dot inspect. This is going to dump a lot of horrible crap on screen, but it's worth just for the sake of making sure that we got everything. Ah, Miss Minty! Nice to see you. Everyone welcome Miss Minty. Gamer friend of mine who has an interest in all things tech and a lovely person. So, we didn't even see, we're probably going to dump this CLR version thing again. Okay, here we go. Man, I've gone over. So it's going to finish at 9:30. We've got to see this at least appear, right? Where's the CLR version in here? Can we see it? There it is, net 35. That's exactly what we want. Okay. So, CLR version is getting spat out. So clearly what's happening here is, for some reason, when we call metasploit payloads.read, for some reason we're not getting the same thing that the Python one is. Metasploit payloads read meterpreter. Ah. Yeah, that's what we want. Okay, I've got an idea. We need to go and look at the gem, just so that we fully understand what's going on. Let's take this one, metasploit. Here we go, metasploit payloads. Whoops. So in the gem, there's going to be a lib, and here I think we're going to see some code. Real path. So meterpreter path self.read path parts. So we know that when we went meterpreter path, it returned path subfolder name.blah. Here when we go self.path, that figures out the whole path for us. But when we go read, it calls path parts. Aha, so the read is different. Okay. Path meterpreter subfolder. So that goes expand data directory file dot join path. Okay, so if we read, oh sorry, wrong shortcut key. So if instead we go path equals metasploit payloads dot meterpreter path Oops. Maybe this will work. Cancel, exit. Let's see what happens here. Come on. Okay, so it didn't do anything different, did it? More debugging required. Oh no, see that's... I have an idea, a different idea. So let's go ag. We want to do load RDI DLL, and we're going to do that in code Metasploit framework lib. Right, okay, so we figure out the path, right? And the load RDI DLL comes from here. Load RDI DLL file not open. There it is. So I'm just going to take this. That's hopefully going to solve the problem for us. You guys all with me? Too busy having fun by yourselves, I don't blame you. Oh, there we go. Okay, we can see it now. Let's get rid of that inspect. That's better. All right, here we go. Hopefully we'll actually see stuff. No. Hang on. Let's go back here for a minute. It's connected. And it's going to hang while reading because we're not getting any data. Come on, what's going on? Oh, is it this? When we dumped this before, let's just have a look at what those first couple of bytes look like. So we've got MZ, followed by the size of the binary, which should be... Is that right? Okay, so XXD of code, Metasploit, framework, data meterpreter, metsrv, pipe head. Okay, so this is interesting. We didn't actually patch any bytes. So we got the 4D5A, 90, but we should be patching the bytes that comes out. And for some reason it's not doing that. Ah, that's because that would explain so much. My wingman have let me down again. 2150, come on. Oh, hey Sphinx. I'm sorry, I didn't see your message there, mate. Got lost in a little bit of noise. We're building a CLR implementation of the Meterpreter payload. Ooh, check it out. Something's actually pinging me on... I wonder what it is. Where are those connections coming from? I don't think I've got a port forward or anything set up. Is there a Meterpreter? Oh, there's still an old Met running. That's probably why. Hooray for resilient transports, right? Boom! Look at that. Oh, we're so close. Alright, here we go. Full stage size. That's big. I don't think that's right. What do you think? That can't be right. So what we do first is we read int32, which says huge, and it's got 4A5D in it. So that means that the stager has not actually put the length at the start, which I would have thought it did, because if we do the ag thing again, because stage Meterpreter is, there you go, see stage payload, which I can now undo because we know that's doing exactly what it should do. So stage Meterpreter, have I got any others open? No, I don't. Let's just open up the Windows Meterpreter loader, because I want to just make sure that it's not returning it itself. So it returns stage Meterpreter, which returns just the DLL. Okay, so whatever's invoking this should be taking that and wrapping it. So Meterpreter code metasploit framework lib. So we've got, ignore the migrate stager for now. There you go, these are all the Meterpreter loaders, so there must be a module that calls it. Here we go. What do we got here? Ah, check that out. So singles all reference it. Oh, we need stage payload. Modules. Sorry, I got that wrong. Stage payload. So here we go. Python, multi-Java. Ah, we've missed something. Payload stages, Android. So what I need is a modules, payload stages, something Meterpreter. What's interesting is that there's no Windows. Let's see what this does anyway. Generate stage. Okay, so that should still work. Because generate stage, you would assume when it's called. You can see it's called all over the shop, including in a spot that we haven't. So in our stage, we haven't got our generate stage set for payloads. So if we edit code metasploit framework modules, payloads, stages, Windows CLR Meterpreter. We don't have a generate stage in here, do we? But then again, can't see Windows either. So I wonder if there's like a generate stage in lib. Aha. Single Android, Windows, payload generic, simple payload.rb. Yeah, okay, I see. So generate stage is definitely being invoked. It's going to be this thing here. Generate stage. If stage assembly and not stage assembly, then me raw equals blah. Substitute vars raw. If encoding is enabled, which it shouldn't be. So then P, there is no intermediate stage. Sending stage. So we know we're getting there because we're getting our sending stage of however many bytes. Okay, so sending stage to blah and then con.put P. Okay, so P is not getting the length prefixed. Why is that? Substitute vars, stage payload. Why is that not happening? See you, null mode. Thanks, man. I've got 4 minutes. 4 minutes to figure this out. Let's just do that stage payload thing again. Let me just see what this does. Yeah, generate stage. So stage payload is definitely lib. Let me just see what this does. So I want to see where the length is shoved in. Stage payload, stage is doing the same thing. Generate default stage. Met.length. Okay, so why is it not there? Metasploit Meterpreter. I would say Metasploit Meterpreter, Ruby, C#. Probably the biggies. But yeah, you'll see that we're actually packing the length in just there. So why are we not seeing that in the Windows one? That's fascinating to me. Windows Meterpreter Loader has it. Reflective PLO inject. So these all define it. Reverse hop HTTP. That's just got redirect actual. How about this? Is this where we looked at before? Yeah, that's what we looked at before. Is this what we're doing wrong? Maybe that's our problem. Metasploit framework lib payload. No, that's not going to be it. DLL offsets, bootstrap length, DLL. Generate config. Like there's literally no reference to the length here. Can you see? Am I missing something? I think I'm missing something because for some reason there should be a prefix of a length being put in here somewhere. I don't understand why it's not appearing. All right. As frustrating as this is, I have to leave it here because I promised I would stop at 2 hours regardless, and I've got work to do. So I'm just going to freeze these VMs, and in a couple of nights' time, we're literally going to pick up from where we left off, right? No, this is actually just patching the bootstrap header into the DLL, so there's nothing in here that's doing it, which is pretty upsetting. But we will figure this out. Yeah, I know. What? Yeah, I hear. Ozjock's probably waiting for me to get back to work, so that's why I need to love you and leave you. But we will come back to this and we will fix it. But as always, thanks to everyone who's followed and subbed and sprayed bits and all of that other wonderful stuff. Played with the new emotes. Barney, thanks again for throwing subs at everyone. Super appreciate it, mate. And you know, fingers crossed that in a couple of days' time, when we get back to this, we don't have the same problem. So, and thank you, Sphinx, for the follow. It's nice to have you along. Feel free to ask questions along the way. So, anyway, I will put a kibosh on it. Trust me, right now, like, it's grating having to leave this, but I really have to do it. So, but thank you as always for everyone, and the support and the conversation has been fantastic. You guys are all really great. So thanks for keeping the spirits up and for entertaining people. And until next time, look after yourselves, be good to one another, and I hope to see you again in a couple of days' time. All right. Thank you.